There we go. Okay. So I'll go back to. So now we're officially sharing my, uh, and then we've got Kayla there. Hi, Kayla. Hi, Kayla. Okay. And then, okay, nine. Hi. Okay, good to have you. We have some of our former students here. We've got current graduate students. We've got PhD students from the IMBS program. So one of the things we have going on in this class is that we've got a couple different things, a couple different approaches. So we've got people who are probably really comfortable with statistics and working with data, and we're going to give them some geoscience training. And then we've got some people who've probably taken some GIS classes, some people that are really good with GIS that we're going to apply statistical methods to this class. And so, like I was saying before, we've got 4 different sections of class within this class. So we have face-to-face master students, online master students, because we recently started up an online master's program, even though I don't think we have any online master students taking this class. Undergraduate students, graduate students. Hey, Alvon, how's it going? And then we also have some PhD students from the INBS program who probably haven't heard of anything from GIS, but you got to real quickly because I was a mentor for a PhD student who just graduated in the spring, and we got her graduated and published in a paper that's really, really neat, doing some neat data development using some of the data that we're going to be looking at here. And so it's really kind of exciting. I've kind of highlighted some of those things as well. Now, those of you taken my classes before, you know I like to have everything set up in one place, ready to go, and you can look at it and see schedules. And I've done a lot of the work already before, and so that we just kind of do more of the work and fill in the blanks and do everything else right here. But this is our applied geostatistics class here. It's going to be anything earth science, environmental sciences. We can map sociological, physical, psychological phenomena, whatever we want, because we've got some people coming here with political science backgrounds, food desert backgrounds, environmental science backgrounds. And so all these things are going to have a spatial component to which we can do those. And at the very least, you can just kind of check the box and get out and kind of be equipped with a new set of skills. To me, this was one of my favorite classes to take in graduate school because, not because the teacher was any good, but because I learned a whole new set of skills above and beyond just clicking and pointing. I had worked in the field making maps for the military for a few years before I decided to go back to graduate school, and I took this class and didn't even realize all the other things within GIS that we could do. Up until that point, I thought I was pretty good at GIS, and then, there's a whole set of tools out there now. And those of you, as we start taking this class, you'll realize there's a lot of online GIS, there's programming. I offered a field mapping class where you go and collect data, using your phones and drones and all this other stuff here. So to be honest with you, I don't think there's any one person that can be an expert in all facets of GIS. The way that I thought I was an expert, 18 years ago or whatever, when I got into it about 25 years ago when I was still doing command line stuff. So, big thing about this announcements, I post everything in announcements here. And so for this class, what I'm going to do tomorrow, I'll post a summary of what we did. If the class recording worked out, I'll post that as well. That'll just kind of add things to our presentation and some of the hands-on things that we've done. But I'll post what we did, what's going to be due for graduate students, what's going to be due for undergraduate students. And so for graduate students, this includes PhD students, you need to write a paper, hopefully a paper that maybe we could submit to a little journal, and I'll show some examples of things that we've done. Already in here, I've posted a couple papers that we submitted already. Those of you who are undergraduate students who are thinking that you might want to apply this for graduate school instead of having to take this class again, you can either do one of two things. You can sign up for this as a graduate class like Benjamin did. So he's an undergraduate student. He's taking this, and Lauren too is taking this as a grad student. So they're going to have to do the paper and any of the other requirements. Or if you're registered as an undergraduate student and thinking about taking this as a grad student, just do the paper, do the extra stuff so that when you sign up for it in our grad program, we can just, you don't even have to show up. So there's a couple people in this couple of people who are registered who already took this class as an undergraduate, took it as graduate class, and so I just said, don't show up. You already did everything. And then I've got one student who's registering. I said, all you need to do is a paper and then do the extra assignments because you already, quote unquote, took the class, and then I'll average that in with what you already had. I'm more than happy to work with everyone kind of in that realm as well. But I've got the announcements right here. The syllabus just pulls from the assignment. So if you look at the syllabus, all I've got highlighted here is exercise number 1 next week. Esri assignment number 1, which is using the software. We've worked with a software package called Esri, Environmental Systems Research Institute. So some of you have been here before, know exactly what we're doing. Alvon, I know you use Esri stuff for a living, right? So you do this for, he does this stuff for a living here. And so some of you are being introduced to Esri, very first time. And some of you it's going to kind of shake some of the cobwebs off from the summer or taking this previously. And then the position paper, which is due in November. And so this position paper is going to be something that's going to reinforce some hypothesis. And we'll get more into those later here. Under modules, I've got everything here just sitting under modules, ready to go. So you can see welcome to GIS class. I'll talk about the syllabus a little bit, the class overview, my information. I put in a lot of videos here. And then under each week, I have every single thing that we have. Don't worry about everything listed here because most of these are just YouTube videos that I created that you can refer to that encapsulate some of the skills here. So someone like Lauren or Benjamin, they know how to run a spatial join or tabular join or how to make maps or running spatial queries. Where you like to say, yeah, of course I remember. This is easy. But these kind of encapsulate some of those skills. And so those of you taking this new, well, you're going to take an Esri class that does this, and then we're actually going to, in the second half of class, kind of open up a GIS and kind of go through and do this ourselves. And I've got an Esri exercise that'll be due in 2 weeks from now, so we're not rushing too much. It's just intro to GIS where you go through and learn the skills. By this point in time, everyone who has an NCC username and password has been given access to the software so you can sign into the training and do everything. You'll have your own cloud space and whatever else that you need. So after our break today, when we start working on the hands-on stuff, you'll be able to log into the software, open up the software, and kind of put it up from anywhere that you want because the software is easy to download and install. Getting access to it, that's the problem. That's where I come in, where I give you the NCC username and password, and you don't have to remember another username or password because I hate doing that as well. And then we can do that. And then I'll kind of talk about the syllabus right here. So this is the syllabus under modules. And so you'll see right here, this week we have a couple of exercises due. One's due next week. The other one's going to be due in 2 weeks. And to be honest with you, probably the one due next week, I can make it due in 2 weeks. But, I want to make sure exercise 1 isn't due in 6 weeks now because the skills that we learn in exercise number 1 will be building on number 2. And in this class, what we're going to be looking at is cancer deaths. Okay, why cancer deaths? Well, this was an old data set that I had, but I think it's germane to the people, our PhD students in the INBS program, as well as it's just the phenomena that we can run things like spatial joins and everything else. So we can turn that into whether it's mental health phenomena, earthquakes or hailstorms or tornadoes or health outcomes or COVID. And so we can spatially analyze those as well. And so we can see these. So I've got a lot of videos here, but I've got week 2, week 3, and like I said, tomorrow I'll kind of run everything and say this is what's due next week. This is what's due of the undergraduate students. This is what's due of the graduate students. So there won't be as many requirements for our undergraduate students. But up in the top under modules, I have a class syllabus right here. So I've got a class syllabus. And I'm not sure if everyone everyone's looked at it yet here, but this class here, I really like this class. It gives us a lot of these aha moments, if you know what I mean, that really kind of elucidate things. And before I kind of go through my little spiel before our break, I'll highlight some of the papers that we've done that you're going to be able to do. About a year ago, we had a PhD student come to me who was kind of floundering in the program and said, I really want to take my wet bench stuff in a particular direction, and I'm going to show you some of the neat stuff we did and the publication we did. And we can apply that to voting phenomena. We got another paper that we did here with Dr. McGinn. Another thing we did with food deserts, which is kind of my specialty, which I fell into right when I got here at Central. So you can see the learning outcomes for this class here. We're going to integrate skills in this class to address problem solving. I don't know if people hear the term translational, but what does this idea of translational science mean? We go from theory and wet bench and learning stuff to really applying it in the field to people who need it most. Kind of that transcends everything. Me, I like to sit on my computer and do lots of stuff, but to me, to be honest with you, it doesn't really mean anything if people aren't being impacted, especially people in marginalized communities who can benefit from our research. So people like Ben who go out and work out in the community, help folks like them, and hopefully we can do research like that impacts air quality or water quality or mental health or gerrymandering or whatever else that you want to do. So you can see my schedule here. I'm typically here Monday, Wednesday, Friday, and I try to be here on Tuesday. I live over in Greensboro, so it's a bit of a drive here, but this is my web page, email, all that other good stuff. I think I have my number here if you need it, if there's an emergency or anything like that. But I go to bed really early, so this is like my late nights for staying out just because I have to drive home. And so typically with emails, I'll respond within 24 hours or the next business day on the weekends. I've got tons and tons of videos that I've kind of posted up there, learning videos, some of the things that we've done, student presentations. Any master's student taking this class is going to have to make a video as part of their research, a 10-minute video, and we're going to post it to our YouTube that highlights your project. So it's going to be required. It's going to be worth 20% of your final project. So I'm really excited about that for you being able to utilize and perpetuate some of these soft skills. Yesterday I met with one of our undergraduate students who was pretty good and said, I've been to a bunch of interviews, but I haven't gotten a job. What is that telling me? They're not good enough of a person? If you're getting an interview, what does that mean? You're good enough, you got the skills to hire the job. So what's the disconnect there? Something's happening in the interview that, you're not getting the job. And really perpetuating some of these, soft skills so that you can go and meet people, go and get these jobs so that people can say, this piece of paper says you're really good, but when I meet you in person, do I want to work with you, and do I have the skills to go out and meet with professionals? Me these days, I'm always looking for people who, project managers, go-getters, just take off with it. And some people have, some of my recent graduate students have really set a high bar in terms of, we got a project with the Region 7 mapping district, Region 7 health district out of Wake County, and they just go and deal with health professionals and make maps for them and collect data, and I don't even have to do it. I just cut them checks and they go and do it. And on the other end of things, I have students saying, I finished this up, tell me what to do next, or I don't know how to do this, or you haven't told me what to do yet, so I've just been collecting paychecks for a couple weeks. So we're really looking for people who can really perpetuate these project management and soft skills to really be kind of go-getters and grab the bull by the proverbial horns. But that's kind of what that project's about, because it's really easy to talk about your project. How do you put it into 10 minutes? That's the challenge. Our research paper is going to be 4 to 6 pages. The challenge is keeping it 4 to 6 instead of going long, going too long on these things. But you can see this is what's required for the class here. Top rubrics for graduate students, the bottoms for undergraduate students. And so we've got Esri tutorials. These are just tutorials that are run by the software. We've got 8 lab assignments, so like a weekly assignment. We've got a position paper. That's the paper I was talking about, where you take a position, you make a hypothesis, and then you go prove or disprove it. saying COVID rates are higher in urban areas than rural areas. And then you use the statistical and geostatistical tools that we learn in this class and other classes to prove or disprove it. In this class, it's okay if you found out your hypothesis isn't true. It's okay. You found out an answer. A lot of times people want to kind of pigeonhole or try to force a round hole into a block, a square block into a round hole with some of these things, and that's okay if it doesn't work. And then we have 2 exams, a midterm exam, a final exam, and then we've got readings. These are all my readings that you get to read and kind of answer some questions about and some of the things that we've kind of published. The exams in this class are always open note, always open book, because you're never going to close the book and do these things. And most of them are going to be they're all going to have some sort of hands-on component where you go and it's not going to say, look up the definition. It's going to have, answer the question, open up the data set, what county has the highest or lowest. So there's a good hands-on component with those. And so the rest of this, you can see the position paper, you're going to go prove or disprove something, okay, using some of the geostatistics here. We've got an exam, 2 exams, a midterm and a final. We've got withdrawals, all those other things, some other class expectations that I've kind of highlighted as well. And I've kind of just got a breakdown of what we're going to be doing here. So just pay attention to announcements because we got a grant with NASA and they're trying to send me out there in mid-November and maybe even in October for some things. So the schedule might be a little updated where I need to consolidate typically weeks at the end. But you can see exactly what we're doing, and tomorrow I'll encapsulate those in an announcement. That'll say what's required. This week, we've got an Esri assignment where you just follow the book, and then you got a homework assignment, which we're going to start in class, when we finish up. Last couple things I'll talk about before my talk here is these are some of the papers that we've done. A lot of times with geostatistics, like I said before, this is one of my favorite classes because we can go and prove and disprove stuff here. And so this is Alana. Does anyone know Alana? She was a PhD student here in the INBS program, and probably about maybe last October or so, Dean Ahmed came to me and saying, she's really having some problems kind of converting her wet bench work to application, and she wanted to look at African American female breast cancer death rates. Look at that phenomenon. I was like, well, I got a big database of everyone who's died in the last 20 years. Let's query out African American and female and breast cancer and start to look at those rates to see how they compare to other rates, other ages, and then create some statistics attached to these. And so you can see she just graduated over the summer, and we got this paper kind of published here. But you can see the idea here. We love this stuff. We got all these things called p-values that we talk about, but we got these little charts right here. But this is where I kind of helped out here, where we went and built the mortality rates here. These are the mortality rates of breast cancer here throughout North Carolina. Now, that's not a big deal because a lot of times, and I've talked about this before, what ages of people tend to die at higher rates than other people? Is that old people? Yeah, that makes sense. Old people too. And so, basically, if you're making a map of any type of mortality, you're just mapping where the old people are. And so we could do something called age grading where it standardizes or normalizes or weights, and we'll talk about that in about chapter number 3, weights the age, and then we can kind of group these into little clusters here. And so we can see these areas in red have extremely high rates of cancer mortality surrounded by other areas of high cancer mortality, and these are collected at the zip code level. So if you go to the North Carolina Vital Statistics database, it's got a list of every single person who died. Doesn't have their name and doesn't have their address, but has their zip code. If you have a zip code, you can map it. And for each person, it has what they died of, cause of death, age, race, ethnicity. It's probably got about 50 or 60 different categories or attributes used to describe those. And we're going to be looking at those for breast cancer or cancer death rates. We're going to open up a map today of cancer death rates and look at it and say, wow, that's just a lot of cancer deaths here. Okay. How close are they to chicken processing plants or point source locations? Or were they smokers or non-smokers? Okay, were they born in state or out of state? Because these days there's been a lot of research into what causes cancer. Is it your diet? Is it your environment? Is it your genetic predisposition? If your parents had cancer, are you going to get cancer? What's the contribution to those? And so we've got some biology people here. We've got some INBS people here that I think can probably answer those questions a little better than me. But these days, a lot of it's going to be environment, exposures, diet, all that other stuff, even though, genetics does play into it. So these percentages are really interesting. But what she looked at here, what do we know about these areas here in red, especially these areas in the eastern part of North Carolina? High income, low income, high minority, low minority, what? These are your majority areas up here, Northampton County, Warren County, high African American. Down here, what's the ethnicity down here in Robeson County? Native American. Native American here. Do you think it's a coincidence that these two areas just happen to be really high breast cancer death rate, hot spots over the last 16 years? I don't think so. Now, what causes it? There's environment, access to healthcare, socioeconomic reasons why we have some of these here. Okay, maybe race plays into it a little bit as well. But we can make some nice maps like these and then look at what is the median age? What is the percent minority? What is the percent poverty? What is the percentage of people who receive SNAP benefits? And we can say, hey, these areas in red have 37% minority, while the areas in blue are 23% minority. What are the chances that would happen? Not really high. It's like 1% chance we just throw some random data together and we happen to have that much of a difference. And so we can look at statistical differences. COVID rates are going to be higher in urban areas and rural areas. If in one area it's 100 and the other area it's 101, that's not that different. But 37 and 23, that's pretty different. Especially, we'll bring into this discussion things like sample sizes and everything else. And so we've kind of looked at these here. Another thing that we were looking at here, and this is great paper. We got this knocked out really quickly, and does it say when it was published? Like hot off the press, like literally a month ago. So they received it May 12th, and we published it July 15th, 2023. Got this out really, really quickly and got her on to bigger and better things. Another thing was, this was a paper, this is earlier this year, where we talked about the idea of rural. What's the word rural mean? Let's get real qualitative real quick. But whatever I say an area is rural, what's it mean? Kind of know. Not a lot of people, right? Well, how do I define not a lot of people with a GIS? Because me, I'm not a big, I don't know how to convert not a lot of people into this on a map. There's actually like 9 different definitions of rural across different agencies. Some look at population densities, some look at how many people are leaving that area to commute to another area. Some look at the actual population itself as opposed to population density. And so when I look at actual maps right here, like you can see these areas in red, these are all different rural areas according to different agencies. Okay, one by the USDA, one by the USDA, one by the Office of Management and Business and Management, one by the census. So which one's right? Are they all right? A lot of times when we talk in research or applications, I just say COVID rates are higher in rural areas than non-rural areas. Well, what rural area are you using? Big difference. No one's ever qualified that before. So some of the things we did in this class is we ran something called an ANOVA, or in this paper, an ANOVA. Has anyone heard the term ANOVA before? Maybe some of the statistics folks here are the PhD students there. Okay, but ANOVA, it's called an analysis of variance, meaning I've got one method, the median income is 43,000 versus 40,000 versus 41,000. Meaning, like, they're statistically different. But they could be statistically different depending upon the way you define rural. Some of them are the same, some of them are different. Which one's the best? So we got that paper there. Another one here I'll mention, we've got a political science major in here, right, Zanaya? Political science major. What we looked at was and this was a short paper here, but we did a paper, Dr. McGinn, who will teach a class next fall. We wanted to see if there was a relationship between by-mail voting rates and COVID, meaning that if COVID rates were high somewhere, they stayed home and didn't go to the polling place. And so we had to go through all the voting records for the entire state. So how many voters do you think are in the state of North Carolina? Like 7 million. 7 million voters. And you can go to the State Board of Elections and literally download that big list of all 7 million people, and it tells you how they voted. And it say, hey, you go to Tim Mulrooney, I voted early, so I didn't show up on that Tuesday of voting. So someone else maybe mailed it in. Someone else didn't bother to show up or whatever. Someone else had a provisional ballot, which is Dr. McGinn's specialty. So we went through this big database. We made this nice little map right here. That has by mail voting rates. So you can see by zip code the rate at which people voted by mail. So you can see in the research triangle here, you had a much higher percentage of people who voted by mail as opposed to areas here along this 95 corridor here. In addition, we've got COVID rates, and we're collecting COVID rates on a monthly basis. So we collected COVID rates around the time of the election. Because if it was now, well, we really wouldn't have a lot of correlation. And so we also mapped COVID rates around the time of election. I think this is like 4 or 5 days before the election, as of October 31st, 2020. We were all out trick-or-treating. I'm sure I was out taking my kids out trick-or-treating. But once again, we see these red and these blues, meaning high rates surrounded by other high rates, low rates surrounded by other low rates. So it's just some isolated zip code over here that happened to have a really high rate or outbreak didn't count because it's not part of a hotspot. Okay? And what we did, we've actually found the opposite, so we ran all this analysis, all this other stuff right here. But we found the exact opposite was that high COVID rates had low by mail rates, meaning that it was the exact opposite of this was the spatial analysis, this was the aspatial analysis. And so you could see that low COVID-19 rates had much lower low COVID-19 rates had higher by mail rates, which is kind of counterintuitive to what we wanted to see. Well, not wanted to see, but it came out to be the exact opposite. And then when we look at the things that impact it, we actually saw that the highest rates of COVID were like urban Democrat, zip codes around the time of election. So we kind of broke it down by that. And then we also broke it down. We did something called a regression. Has anyone heard the term regression before? Okay. But regression, what are the factors that are going to impact COVID-19? It'd be really silly if I went through all this analysis and or by mail rates, and someone said, you know what, maybe just all the people who voted by mail in 2016 were the same exact people who voted by mail in 2020. That would have been really silly. So I ran something called regression. It doesn't have a little star or a little A here, so it made me feel good. So things like income, high income areas, I guess, had more of the resources so that they can vote by mail. It was also attached a little bit to race, percent minority, as well as access to transportation. And so we've got all these kind of neat things that we can do with this, but we've got applications that transcend, your physical sciences, your earth sciences, your environmental sciences as well. And so what I'm going to do here is kind of give my little spiel. We'll go through a break here, and then we're going to open up exercise one. And just those of you open up GIS for the first time, you can see Benjamin's over here already going through like the data definition tables and all that other good stuff. But if we're open that thing up, right? I think it's really ugly really quickly. And that's what Alana and I went through, all those columns of what they mean, and it gets really nasty really quickly. So basically, I'm going to give my little intro to data, spatial measurements, statistics, because you've already heard this before. Those of you who've taken my classes, GIS is hardware, software, data, personnel, so we can manipulate and create spatially related information. It's not necessarily a GPS, because we carry around a GPS in our pockets at all time. It has very rudimentary capabilities. These days, you can type in an address, you can do directions, but you can also collect data. Okay, we can collect data about the food environment using something called Survey 123. We could do some trackers. We could take some surveys that have GPS related information. Now, how good is the GPS unit on your phone? Is it good? It's okay. Right now, I'm trying to buy a new GPS that kind of connects to this, that kind of gets down to about a meter or so. So that's okay. It's not a particular software package, even though the term Esri is used. And keep in mind, these notes are already posted for you there, so if you want to append them, that's fine. But these notes are up there, as well as a recording that I've already kind of pre-recorded here. And it's not necessarily a static map. And these days, these are the types of maps that I used to make when I worked for the military. Well, most of you know the answer, but the second that this map gets printed out, what does it become? Obsolete and old. And so these days we've got these maps, but we love looking at these maps here. We love these. My wife worked for the phone company. They love these maps here where you could draw stuff on those. Draw station locations or new lines and telecommunication lines where they had. These are very rudimentary forms of GIS, but these days it's all done here. It's all done using our more powerful desktop software. I'm a big fan of the desktop software just because it's got more capabilities, but we can access and store data sitting there in the cloud. But your most expensive component here of your GIS, and when we actually look at a physical GIS, most of your cost is in people and data. Okay, how much does an average GIS person make? Well, you go to Indeed, you can type it in. It's probably, starting, $50,000 a year, working your way up right there. And then the cost to make data, making data from scratch. We teach a field mapping class where we go out and fly a drone and collect imagery of just, the area, the courtyard right there, and it gets really, really ugly. It's really ugly. We have hardware and software. We're looking at about $1,000 computers here. The software doesn't, cost that much. There's even stuff like QGIS. Do you guys use QGIS at all, or?
Try not to, but you can.
Yeah, you can. It's free. It used to be called something used to be called Grass back in the day, but you got software out there that's from free to pretty expensive. But what this class focuses on is what we can focus on is the procedures. Let me answer something from my mom. My mom's texting. And so in this class, what we're going to focus on is the actual procedures. The actual procedures. What are the things that you do to GIS to make those red clusters and blue clusters and everything else? Because the first law of geography is by Waldo Tobler, who says everything is related to everything else, but near things are more related than distant things. Which basically means that when you look at income for a particular area, high income near high income, low income near low income. Whether it's, we're looking in the back right there, of age-adjusted suicide rates, AIDS mortality. Believe it or not, this map over here is of ADHD. So ADHD rates, you think of it as being like a stochastic in nature, like kind of something that's random, but you can see there. Okay, up above Ariel in the back corner here is birth defects. You think birth defects are kind of random, but you can see they're really high in the southeastern part of the state. Now, I'm not the Y person on it. I don't know why. You all figure out the why on those, especially, our masters and PhD students here who have other specialties like psychology, biology, political science, or whatever else. And so for GIS, the purpose of geographic inquiries examine relationships between geographic features and to describe them in the real world in which they represent it. GIS is basically an abstraction of the real world. So we're going to look at cancer deaths, literally like X marks the spot, where they lived. But where they lived 10 years ago, we don't know that. It has the state or whatever. And it's the quantitative procedures employed in the study of the spatial arrangement of features such as points, lines, and polygons. Where have you heard the term points, lines, and polygons before? Math class. Now, instead of calling them X and Y, we call them latitude, longitude. So that real-world distance can be measured between each of these points, lines, and polygons pretty easily using our desktop software. And so we can just see a couple of kind of relationships or a couple of more descriptions of GIS here. But in geostatistics, in this particular class, were the application of statistical techniques to spatially related data. So we've probably all heard the term mean, median, mode, all that other good stuff. Clustering. Okay, z-scores. What about z-scores? Does that ring a bell here a little bit? Maybe. Good. That's okay. Okay. So we're going to apply these to spatially related data. The first probably 3 or 4 weeks, we're going to open up Excel. We're going to do the mean, median, mode in GIS because we really hadn't done it before in 34-35 or our applied GIS class. And so this class is going to talk about descriptive statistics like your mean, median, mode, making nice little histograms. We're going to talk about inferential statistics, meaning I have a bunch of points up here. How does that compare to random data? Meaning I've got that AIDS mortality up there. Well, if I just had random AIDS mortality, how different would that map look? We're going to have correlative statistics, meaning what are all the quantitative factors that impact or affect by-mail voting rates for 2020. And it wasn't by-mail voting rates, so things like income and race, which dictated those. And so at the end of the day with geostatistics, our end goal is to facilitate and reinforce data-driven decision-making. That's the whole goal. The days of I feel like are gone. Whether it's a new treatment center or food distribution facility or wherever, or these days in sports you hear about the idea of analytics. What's analytics? Data. Okay, you're not going to pitch to this person a third time they come up because they're hitting 400 against you or whatever. Are we going to go for a fourth down in this situation? The days of I feel like are long gone. So in this class, we're going to have kind of an understanding through chapter 6 and 34-35, and our PhD students here are going to kind of play a little catch up at the beginning here to kind of capture those in the first few weeks. And we're going to talk about some of the different applications that transcend everything. This is one of my first PhD students. He came to me from North Carolina State. And so what we looked at was deer vehicle collisions. He was into deer vehicle collisions. He was an ecology student over there. And so why do we care about patterns that aren't random? If they're not random, where are they most clustered? So when we look at deer vehicle collisions, these are a map of deer vehicle collisions. Here they are. What does it look like to you? But bunch of dots, right? Just a bunch of dots. But what I can do is I can group these by census tracts or block groups. I can group these by little squares. Why are these little squares maybe better than tracts? These things are called quadrants. We'll learn all about these. But why are these probably a better solution than this? What do you say, Benjamin?
Oh, because census tracts are drawn around human population.
Yeah, we're drawn around human population. Some are big, some are small. These are all the same size. So I don't need to calculate density because they're all the same size. So if these are 1 square mile, I know these ones with the bluest have the mostest. Okay. So we have these. And I can create the size of the tracks using this little formula right here. We won't worry about this for a few weeks because I can make these kind of little squares really big. But if you only have 4 of them there, do we really need to study a geography? Probably not. It's not geographic in nature. If they're really small, you're probably going to have a lot of zero values. And so I can create or see what these patterns look like to something called a Poisson distribution using this big nasty formula here. Now Excel does this for you, so you don't even have to type any of these things in here. I can say, what does it look like? What is it supposed to look like in a random distribution? Say, hey, these kind of look the same. We do have a Poisson distribution. I can map the density of these. And in applied GIS class that we finished up with this spring, we mapped densities. So I can do density mapping because the deer don't really care about what census tract they live in or which little square they're in. No. And then I can group that density by quadrant here. So maybe I can compare the number of highway miles or land cover or urban and look for associations between those. Yeah, I can make graphs that look like, oh, what's the relationship between the distance to low impact urban versus deer density? And then we can make decisions like this. If there's a deer crossing sign, why don't we move it? I thought this was kind of funny, right? A lot of deer get hit by cars in Crown Point. I think this is Indiana. There are too many cars. Deer crossing sign needs to be moved to another place with less traffic. Well, the deer don't really care where it's letting people know. Some ancillary issues that we talk about, and in chapter 13, we kind of mentioned those. And whenever you write a paper, you always have something at the end called the discussion, meaning these are all the things that I could have done that maybe might have changed the results. Meaning, should we only include full quadrants? When we run density analysis, we can create something called a buffer. Has anyone heard the term buffer before? If we look at that North Carolina sex offender registry, you can see 1 mile buffer around your house, 3 mile buffer around your house, 5 mile buffer around your house. Obviously, the bigger the buffer, the more values you might have. What's an appropriate buffer for bear or deer or any other type of animal based on contemporary research? And what's an acceptable radius for your deer density? Maybe deer only stay within a mile, so we don't need to calculate these. So you can see an example here of some of this analysis that we did previously. This is a paper that Samuel and I just finished up where we include the density outside of the stores here. So you can see these people who live over here in Chatham County. There's density calculations over here because, well, people might go from here to here if it's closest. And so this area might not necessarily be an island. Another thing that a project a student did was alcohol-related fatalities. And so he made a map of this, alcohol-related fatalities and the total number of highway DUI fatalities. This was done by a student named Nelson, and he works for the NCDOT photogrammetry unit. Anyone heard the term photogrammetry before? What do we use photogrammetry for? Use images like drone, satellite, airplane images to make measurements. And they do that with like NCDOT planning or whatever. Now, when you look at this map, Florida, Texas, California, what do you know about Florida, Texas, and California? They got the most fatalities. Why do you think they have the most fatalities? They got more people. So we look at something like this, you're like, oh, that makes sense. And so we can normalize these by population. So the number of fatalities per 100,000 population. Now all of a sudden, Wyoming has about 1.5 times more than any other state. Well, why would Wyoming have so much more? What might be some of the factors? Not that many people. They have higher percentage, so what does not that many people have? The distance to hospitals, exactly. Okay, distance to hospitals, law enforcement, speed limits, all of those other things right there. But looking right next door to Utah, actually has one of the lowest in the state next to one of the highest in the state. Didn't I just talk about the first law of geography saying high values near highs, low near low? Why is the highest next to the lowest? It's in Utah that they would have such low rates, where that in Wyoming they'd have high rates.
Laws.
What about the laws?
Really drinking yourself.
Why not? Mormon. So religion that a lot less tolerant of alcohol consumption. You probably can't even sell alcohol on Sundays. I've been through there, and there's not a lot of like hard liquor or any of that other stuff that you can get or whatever. And so you can see both the environmental factors, access factors, as well as maybe some of the sociological, religious factors attached to those. And so some of the neat things that we did was we have a big spreadsheet, because we could have just listed this in a spreadsheet, but since this is GIS class, we can put this into a map. We can normalize these. So what attributes should be used to normalize fatalities? Should it be area? Should it be population? Why don't we compute per capita? Okay, and these will be some of the bigger questions that we look at here. And so we can look at the relationship between density and DUI deaths. So as density increases, DUI deaths actually goes down. So your most densely populated states, probably like DC, which probably included New York, New Jersey, Rhode Island, have much less than your Wyomings and Alaskas. It's probably access to public transportation. And think of what this might be doing to things like, ride shares and everything like that. That's probably creating even a bigger schism, because in rural areas, can you get Ubers and things like that? Probably not. So people are still going to drink and drive. Other things. Impacts of COVID-19 on voting patterns. I just talked about this one. So I've got some nice maps here. I've got some maps of COVID-19 incidence, death rates. I kind of queried some of these things out. And then basically what I showed right here was that right here, COVID-19 hotspots had COVID-19 hotspots had significantly lower by-mail rates. You would expect the opposite. High COVID, high by-mail. And so in my cold spots, hot spots, they were almost 11, they were almost 9. This is enough of a difference for us to say they are significantly different. And we're not going to do these we're going to let Excel calculate these, but you can let SPSS or SAS or any other statistical software let it do it for you. So we're going to go back and forth between Excel a little bit. Once again, our hotspots of COVID-19 rates. Okay, a lot more apparent than our hotspots of age-graded cancer mortality rates. There's a little bit more randomness there. You can see those, and then some of the factors that impact those. We'll worry about those later. The impacts of annexation. Has anyone heard the term annexation before? It's probably big around here, right? Cary or Raleigh or whatever. Why do we annex areas? Cities just gobble up other areas. Why? We had it about 10 years ago over in Greensboro. They just kind of gobbled up an area and said, now you're in the city. They get out of it. Taxes, exactly. They get taxes out of it. I still live in the country, so I don't have to pay, city taxes, which would be like probably another 20 or 30% more. What do I get out of it? Well, I get sewers and garbage and all that other stuff, but I don't really care. But about 10 years, or this is about 15 years ago, we have the city of Winston-Salem went and gobbled up all these yellow areas and just all of a sudden said, now you're part of Winston-Salem. That entails data collection. So how did that impact crime patterns? Because when I look at the crime database for Winston-Salem, it looks like this big mess, kind of like cancer deaths that we're going to look at. And so we did some point pattern analysis where I calculated the spatial mean, not the mean, the spatial mean. So if I were to average up all the latitudes and longitudes, what would be the central point right there? The population centroid. And basically what I saw was the people moved to the north. We gobbled more people in the north. All the crime moved to the south. So when we look at these areas right here, we kind of gobbled up more people up here than down here, but we gobbled up more crime down here. So how does that facilitator dictate decision making when they do police beats, new routes, or whatever else? Then we also ran some cluster analysis so I could see the crime rates, arrests in 2005 versus 2007. I can run some things called LISAs, Local Indicator for Spatial Autocorrelation, which is the fancy way of looking at hotspots. Look what happened to the hotspot of crime from 2005, 2007. Actually kind of moved to the south. That reinforced it. Now we're looking at an inferential statistic here versus descriptive statistic, and it kind of backs these up. People love looking at these maps here. Love it. Okay, but there's a lot of data prep that goes on in the background, and we'll start looking at that data prep today when we look at some of these raw data. And so these areas down here were high crime areas that they kind of gobbled up. They're collecting money as part of their tax base, but it's changed the complexion of what it looks like, what crime is going to look like here. And so when we look at a discussion here, what is crime data? Is it an offense? How good is the crime data? You can go right now to the Open Durham website and download every crime that occurred in the last month. How good is it? How do you turn in the GIS data? And in the spring, Dr. McGinn and I, or one of us, is going to offer a crime analysis class which focuses explicitly on crime. And then the idea of something called MAUP, Modifiable Area Unit Problem. Do we group it by block groups? Do we group it by little squares? Here's another one, environmental justice. This is a big kind of key term these days, where median household income by zip code. Here are some wood pellet processing plants that they're building in North Carolina. Have you heard the idea of this wood pellet processing? All in these kind of relatively rural areas here. What do you think the relationship between income around these areas versus not around these areas is going to be? Very, very different. Okay? And so we can create these things called buffers. So around these wood pellet processing plants, they're 28%, 50% minority versus 29% for the rest of the state. Let's look at the income. And so we can look at, and this was a project that a student previously did, really neat project that she did, part of her undergraduate work. This was one from a master's student named William, took this class a couple years ago. Is there a difference between patterns of crime from 2019 to 2020? Okay, what happened in 2020? COVID. So did crime go up? Crime go down? I would assume crime went down, but let's see. So when we download the crime for the city of Winston-Salem, or the city of Durham, you get big lists like this. Like 0 Plummer Street. They didn't know, so they just put in 0. Or 300 North Duke Street / West Carver Street. So when you download these things, we got to turn these into a point on a map. Have you ever done that before? Type in an address and it appears on a map. I do this all the time on this thing. Now, have you done it 7 or 8,000 times at once? A little harder. A little bit more pain in the neck. So we're going to do that. And so when we get the different data for 2019 versus 2020, this is what the data looks like. Even then, what does this look like to you? A blob of points. We need to group these by something. I want to group these by census tract right here. I want to look at the rates went up versus the rates went down. Okay? So within each of these, I've got population, so I can calculate the crime rate in 2020 versus the crime rate in 2019. I've got a list of 100 block groups here, 100 block groups here to see if they've gone down. Because I don't have the crimes for over here, because that's not City of Durham. Who collects the crimes outside of the City of Durham? Sheriff's Office, some other county, Orange County, whoever else. And so there's this whole idea of data consistency that we need to deal with too. So I can see if they went up, went down. So 2019, it was about 41.99. For 22, it was about 32. And you can see it's statistically different. Yeah, it went down. Yeah, it went down about 18, 19%. That's enough for it to be statistically different. And that's what this class is going to be. And then geospatial associations. This is the one that I've talked about before. But this is what I did with Alana, with a PhD student. And what we had to do was put together a big, gigantic database of every single person who died in the last 20 years. And when we start looking at the schema, meaning I've got an attribute here called EDUC. I've got an attribute here called race. Now, what do you think race stands for? The race of people. What do you think a 1 versus a 2 versus a 3 means? You got to go to this separate document that tells you what the 1 versus the 2 versus the 3 means. Status. What do you think status means? I have no idea either. And so we're given this big list of attributes, but we can go to this thing called code 1. This tells you what people died of. Anything with cancer starts with a C. We can extract out anything that starts with the letter C. We've done this before in our GIS. Find every county that starts with the letter M. Find any county that ends with the letter D. And so we could do quantitative comparisons as well as qualitative comparisons. Most of these are going to be qualitative in data. The day they died. And then I got a zip code right here. I don't have an address, but I got a zip code. So now I can group every single person by zip code and then look at the breast cancer mortality rate. And you can see that it's going up. Well, the actual number goes up, but the actual rate is going down slightly. And when we showed this, someone was like, oh my gosh, that's terrible. It's going up. But we also have more people moving into the state. And then what we did was we ran a 1-year average, and then we ran a 3-year average. What's the difference? Why would I want to run a 3-year average as well? What does that do? This blue one right here versus the purple. This just might be a really bad year. And so when we average it with the other two, it kind of doesn't make it look as extreme. So a lot of times you hear these days, July was the hottest, month on record. It was really hot in July. Hottest month on record. But maybe if you look at the last 10 Julys, it might not be that much different than the previous 10 Julys or whatever. So this one just happened to be really hot. And so a lot of times, even with climate data, you'll see this kind of 3-year average, 10-year average, 20-year average. The definition of climate. What is climate? The study of weather over a period of time. Isn't it like 30 years or 40 years or something like that? So we don't get into these, oh my gosh, look what happened here. The rates went down and went up so quickly. Maybe it's a bad year, a low year, an anomaly or whatever that we deal with. We can make maps like these that I've shown before. Hot spots, cold spots right here, and start to make some associations. Because at the end of the day, what we have here is that we've got maps as numbers. I've got a few more things I'll talk about. We'll kind of go to our break and we'll start opening up software. But in this class, it's quantitative. In about the 1950s, 1960s, geography went through something called the quantitative revolution, where you think of geography, especially on Jeopardy. What are the questions in Jeopardy about? What do they talk about? The highest, the lowest, the capitals, descriptions, all this other stuff. To me, that's not geography. This stuff here is geography. Now, you can't ask people questions about things like this. But in the 50s and 60s, where we started to get these really high-speed computing or relatively high-speed computing, we could represent geographic phenomena as numbers and start to make these associations that previous generations of geographers just didn't have. And so how do we express points, lines, and polygons as number in databases? How do we express someone who died in a database that can be mapped using their zip code. I know what a zip code looks like on a map. It's going to be some sort of polygon, and the darker polygon has more, the lighter polygon has less of whatever we're looking at, depths or whatever. And everyone who's taken GIS before probably can make these maps, and those of you who haven't will kind of get up to speed on those. Don't be too overwhelmed. Because what we're going to look at today is just a bunch of cancer deaths on top of counties, and like, what are we going to do with this? You know, how are we going to do this? And so we acquire data and maps that are going to be represented as numbers. And so typically when we look at data, this is how we look at data. These are crime events for Winston-Salem in 2006 when we look at crimes, but really this is what I look at. And anytime we have an Excel spreadsheet, we find some neat data. I've got a big list of 1.8 million people who died in the state of North Carolina over the last 20 years. My first question, hopefully your first question moving forward, is going to be, how do we turn this into something that we can map and make the hot spots and cold spots and answer some research questions? Because most data has a spatial component. You know, your patients at a doctor's office, where you travel, where you buy things, where you go. There's usually some sort of where component, where students come from to go to class, we can stick on a map. Some of it's useful, some of it isn't necessarily useful. Because this data can be stored as lists, numbers, tables, pictures, maps, indices. The type of data, well, Hispanic is going to be a number, but a zip code is going to be a number, but it's treated as text, where that the age that someone died at is going to be interval or ratio data. Remember that interval and ratio data we talked about? I'm just trying to see, waiting for people to say, yeah, I remember. Alondra's kind of nodding a little good. So we do know, meaning that someone who died at 35 was half the age of someone who's 70, but someone with race 1 versus race 2 doesn't mean there's twice as much, because that's just a code used to store those. So hopefully we can't run the calculations on those. Because when we store data, we've got records that read across, attributes that read down that you use to describe these. And what we do, and this is what data looks like, but in a GIS, each of these records is linked to a point, line, or polygon sitting on a map that has a spatial relationship that can be measured in miles away from something. So these attributes have physical data models that have evolved over time, but we can store numbers. These days we can store pictures, blobs, anything that we want, but for the most part we're going to be just storing numbers. Percentage of people who live below the poverty line. Population. Some of these are going to be integers, meaning population isn't going to be a decimal, where that percentage of people who take public transportation is going to be a decimal, where that something like percent change might be a negative or whatever. So some of these can go above 0, below 0, or whatever. Because we can ask the how and the why questions, meaning why are McDonald's located and successful in different parts of the world? How do they spread to these locations? Why do we build them where they are? This is over kind of where I live. I used to live over in Greensboro here, and this is Guilford College right here, and they've got a McDonald's right there. And then soon they built one right kind of on the other side of Guilford College, if you're familiar with that, Zanaya. Yep, my daughter's elementary school was like literally right there, So you leave the parking lot and you don't want to cook, and guess what? You're pulling right into a McDonald's parking lot, So now, who does that? People get paid lots of money to go through that and do this. We had one of our former students easily made 6 figures doing this for a living for Lowe's. So they're called business GIS analysts or business analysts, or BIM, business intelligence mapping. People make big bucks utilizing all the socioeconomic data sitting out there, and you being able to utilize this to facilitate decisions. Amazon, they use GIS all the time, meaning on the fly, meaning, hey, you've got 40 packages to deliver. Are you just going to start driving around in your car, in your Amazon delivery truck, figuring out where you're going to go just randomly? No, they're going to tell you that route that you're going to take so that you minimize the amount of time you got to drive while maximizing the number of packages that you can deliver. Because the more packages you deliver, the more money they make and whatever. And then things like tornadoes. You can see the total number of tornadoes, cancer mortality rates, lots of sources of data out there. And so Alana, when we built that cancer database, we had to do a lot of work because the schema changed between like 2014 and 2015, meaning we had race was 1, 2, 3, 4, but then they called it, race decedent, or they called it birth state instead of BRTH state. So they changed the names of everything so that we had to kind of line those up. And so those final maps that you saw were like the last 5% of all the time and resources that we put into developing the data, making sure everything lined up, making sure, all right, we got cancer. Did we include all the 2001, 2, 3, 4 stuff? And so those of you who really want to do some big research into this will kind of really think critically about the data that goes into this, things like gerrymandering or whatever. The last thing I'll kind of talk about is kind of some of these like no-duh questions, meaning, a lot of times you see this in stats, like we hate math, say 4 and 10, which is a majority of Americans. And so when we start thinking critically and holistically about the projects that we want to do, like, some of these are going to be really, really self-explanatory. Like, I want to see if the temperature is warmer in June versus January. Like, we know that. But maybe which month of the summer, which month has the highest humidity? I don't know which month those. And so, kind of answering some of these big questions. Statistics show that teen pregnancy significantly drops off after age 25. I thought that was interesting. World Bank says poor need more money. Okay, cool. Mississippi's literacy program shows improvement. What's wrong with this? They spelled Mississippi wrong, so one talking about literacy. State population to double, babies are to blame. Overall serious crime down, but arsons, burglaries, and homicides up. And those are some of the things that we did see from COVID, was that from April, May, June, from 2019 to 2020, even though crime went down, things like burglaries, domestic violence actually went up, in that time period, which we thought was kind of interesting. Rooms with broken air conditioners are hot, and homicide victims rarely talk to police. So these are some of the things that you kind of see. So hopefully we won't see any papers on these. But what we're going to do now is we'll take a 10-minute break. So we'll meet back here at 6:20, and we'll start kind of just going through the first exercise. And so we can get out of here at 8:30. So I'm just kidding, it's 7:30. So we'll take about a 10-minute break here.
At ECU, like, it's so many, like, you have
I went out there to went out for a meeting like in May or June or something like that.
okay,
Went to some pizza place downtown.
mellow mushroom.
No, I'm not doing that. Some other place right downtown.
Because everything is covered in purple and yellow. Oh my.
Did you like Mellow? Have you ever been to Mellow
That was
Mushroom?
my first.
Oh, okay.
time
We
going.
got one there, and it's just, well, I like it, but it's yeah, a little expensive.
We've got one here in Durham.
Okay. Yeah, I've been down there. I've taken some people down
It's like they have so many food choices, and then like, except for the choices that they had on campus that are actually open. So like for most of my, I ate sandwiches from either out on pan or open. Those are the sandwiches.
What options on campus?
Yeah, those are the, and like they have more. Like they have a raisin station, steak and shake, or
I have some friends race.
salad. I think they have some like other places, but they just weren't open. There were plenty of people on campus to open up. Oh, yeah, fresh.
Like, funny is that you can actually buy the ECUs, like the party school of North Carolina. You can actually buy alcohol with like student credits at ECU. The Chili's. The Chili's on ECU, you can use student credits to buy cocktails.
Wow. I'll be back in a few minutes and more of this riveting discussion. Working on for you. Going, my daughter started a job, full-time real job, and she's
This is what the senior is supposed to say. This is not Did you go to the captain? What? They're going upstairs, right? So, like, they were closing down lines. Girl, I think me, she was like, opportunity. Said, I sure hope so. I'm crying. She's talking about something. Sound Did you get a rose? Girl, I was in class. I had saw Devin Smith afterwards. Like, got nothing else? Well, Wednesday ain't pretty buoyant. How about that? Like, I was so mad. It was like no space in there to breathe. Bed. I was just like, this is oh my goodness. It's okay. You know they got and it was pretty good.
Oh, good. They had the same time.
They switched it up. They had mashed okay, green bean.
Or the top.
It was good. You could ask stuff. That's hard. Yeah. So like people talk. That was about a new week. Yeah, I have a lot.
At least computers work.
They should work.
Some, the power's on the side of the monitor, not
Yeah,
on
they
right
should.
bottom side, a little bump there. Get the button turned on.
Not actually knit fits out.
I have no idea. I've never looked that close.
The hell? I'm doing work from here. I want. Like, let's see. Oh, wait, didn't show us the doc. That's one of the. Lights.
Who's ready to start playing stuff here?
The RTI, the map has it said like, it said the application.
Answer it.
Wow.
Cheers. See you. Okay, what we're going to do here, we're back. What we're going to be doing here is working on the exercises here. Now, the first thing that I did was I sent everyone an invitation. So if I go to arcgis.com, because we've got software, and Kaya's having a problem logging in. I want to make sure everyone can do this, everyone can get the software, because tomorrow, most of you have already kind of gotten in here, but I want to make sure everyone can get in. So when I go to organization and I go to members here, I'm just about positive I've sent a bunch of members an invitation. So a bunch of members here, an invitation here. So you should have gotten something from Esri that says, all right, so you got to check your email, because like Lauren, I already, there's a page.
It was up on my list.
I know that. There we go. I'm going to resend. Boom. Check your email. But everyone should have gotten an email from Esri saying, you've been invited by this Mulrooney guy to log into your login. Also, we need the software installed. So what I'm going to do here is, so when we start looking at our modules, what we're going to do here is today we're going to talk about exercise number 1. Basically, we're going to open up the exercise, we're going to download it, we're going to start working on it in class. Those of you kind of new to GIS, we're going to get the look and feel of working with this thing. So some of the things that you need the actual physical software installed on your computer. So if you don't have it installed, you can log into the computers that we have here that should have the software, like Lauren's already installed. Okay, let me try this. I set all this stuff up. I thought okay. Invite music kpayton4@ad.nccu.edu. Okay. Did it work or no?
Do you have to put the AD, or is it the same as like?
Try doing the ad.nccu.edu. Try doing that. No, sign into the edge. Try it. Do you sign in using the AD or you don't even remember?
I just.
It's working, right?
Oh yeah, so I saw it.
Oh, you signed in using the AD? Okay. Try slogging in there. So, do you get any? Who else is having? Jayla's probably having. Ario, are you good there? Okay. Why? Right members. I had this all set up. New member. Peyton, right? 4. That. just gonna say at Eagles. This is you, right? All right, Alondra just logged in. Okay,
Can you send it to me?
okay. I'm gonna blame someone. I'm thinking of someone to blame first, and then, all right, maybe I have to do it one at a time. A R O Y.
R-O-Y-S-T.
Work for you now, Kaya?
Well, I haven't tried to log in.
Okay. All right, so we're gonna add you as an editor. Did you get an email from me? Or from Esri? Okay. All right. I might have to just do these one at a time. So the reason why these folks have already logged in, so it's not like they're special. But Z Heart.
Mhm.
That's it.
Yep.
Okay. There's no other Z Hearts around. Okay. While I'm working on this, Alondra, think of someone to blame for it not working seamlessly, because I cannot blame myself. That'd be terrible. Okay. James, are you good to go there? You able to log in?
Yes, sir.
All right, Amani, have you been able to log in? It's been a while. I'm not sure if you need any classes to do that.
No, not yet. I haven't received an email.
Okay, what's your email address? Barber,
At Eagles.
BARB.
OUR.
Okay, at Eagles.
Yes.
Okay. Barber at eagles.ncc.edu. Okay. All right, I just sent you something. And Jayla, I saw you just logged in. Cool. All right, Barbara, let me get you here, and let me make sure I get Chantel because she's new. Okay, Barbara, what's your email address?
It's B Grissom, GRISS, as in snake, O N as mom.
Okay. At eagles.ncc. I had all this set up too. Chantel Reddick. Okay.
Who's up there? It's ready. 11.
Okay, let me send it to you again here. Maybe I did the AAD instead of the Eagles.
Oh, let's see.
It can't be my fault.
Absolutely not.
Good answer.
But thank you.
Okay. So a couple things while I'm talking here, and I can just have everyone, all of our online folks kind of face me. Caitlin, are you all set there? Have you logged in before? I'm sorry.
I have.
Okay, all right. So you can log in using your NCC username and password. So I might have made a I can't say the word, but putting in Eagles instead of ad.nccu.edu. But you should all be able to log in using your NCCU username and password so you don't have anything kind of else to remember. Now, the look and feel of this is going to be kind of the same. So when you go to arcgis.com, this is the online version of the GIS software so that you can add new maps and do everything else. But the login is going to be pretty much the same here. And so when you go to sign in, this is what it's going to look like when you sign into the software. So once you sign in on your laptop or you sign in on a computer, you're good to go. And you have your dedicated cloud space. So where's the cloud? It's up there, it's just up there. And we have these kind of, I don't want to use the word dummy, but we have these kind of general usernames and passwords that I've created for my previous classes called like GIS student 2, 3, 4. And so if you happen to log in using those, if you've seen those in any announcements, you'll be storing them in their cloud space as opposed to your cloud space. And what I can do later or this week is I can also add you. Alvon, are you on yet?
It's not actually like all.
Okay. I'm sorry, I need to add you too. But when we click on sign in, you're going to come to a sign in page. You're going to come to a sign in page that looks like this. So you can either, this is my username and password, but right here, you're going to go to your organization's URL and you're going to type in the words DEEGS NCCU. So DEEGS NCCU. I'm going to come around and help everyone here to make sure everyone's logged on. We're not going further until everyone in this room continues. And I'm going to click continue, and then you're going to click on North Carolina Central University. And it'll just take you right to your NCCU username and login. It'll take you right there. So I'm going to come around and help everyone. Let me get Barbara going here. So I'm going to sign in. I'm going to get Alvon going here as well because I thought you already had one already. No, I'm getting a little more sophisticated, so a little bit more. Organization.
Use the one I already have, or have you?
Yeah, if you already have one, use it. Did I give you one pack in the day?
Yeah, we can just add it to the existing directory that you have, so that when I log in, I'm also like use it.
Uh, what's your NCCU username? A.
KLET, BAILE.
Okay. I'll make you a data editor. Okay. So we should have everyone kind of here ready to go. I've added Chantel, Amani, Caitlin's good to go. James, I know James taking my classes and I know James knows what he's doing. So we're good there. So what we're looking at here under exercise number 1, we're just going to look at exercise number 1. Let me get Barbara. do here is double check the word ArcGIS. Log into ArcGIS Class. This is how we log. If you already logged in here, you don't need to log in. So this is the online, so we got maps and terrain and all that other good stuff. Here, it's just the desktop. So what I've got here is I store everything. Those of you who know me, I store everything in zip files, meaning when we start to look at all the points, lines, and polygons, they're stored in literally hundreds or thousands of different files. Do I want to give you all 1,000 files? No. So I put them into a zip file and we just download them. And so we download them right here, and I'm just going to click download, and then we're going to extract those. Now, where are you going to extract those things to? Folder. Which folder? One you create or one you know you're not going to forget. Okay? And so when we download these things, typically on my computer, it's just going to store it into downloads. And so when we look at this thing right here, this zip file that I created right here in downloads, it's called Exercise 1 Fall 2023 because, believe it or not, I kind of go and create new exercises. But if we were to look within it, it's got the exercise 1 that we're going to start working on today, this depth detailed description thing that describes the data, because when we start looking at things, we're going to look at these. GS and I do only got through this month, so then after that, like Lauren, she came in and put these books here. They're like, they're bored here. Now, the one thing about this is still sitting in a folder. So what we're going to do is we're going to click extract, and like Lauren alluded to, save it somewhere where you're going to remember it. Save it to a flash drive. Me, I save everything in a geography, 5130 folder drive, but you can store it wherever you want. So I'm just going to save it here. But because when we start to look at the actual file here, the actual ArcGIS stuff right here, homework number 1, I got tons of files sitting right here. Which one am I going to click on? I'm going to click on the one, the ArcGIS profile, because if I were to get bold enough and start looking at the actual points, lines, and polygons, I'm going to start freaking out. I'm like, I don't know what this stuff is. And so remember, I'm going to click on the ArcGIS profile. The reason why it's got that icon there instead of a white icon is because ArcGIS Pro is installed on it. So you need the software installed so you can open it up. And so you click on the little icon that says homework number 1. Magically, this big map pops up that I've kind of gone through the trouble of creating that's sitting here, right here, ready to go. Sitting here, right here, ready to go. And if you've logged into everything and if you've unzipped it, you're set. You are set. Oh, okay. Okay.
Yeah.
Okay. Let me just, I can sign it.
I had to do it at the break.
Oh, okay. You need to get the campus. Okay.
Yeah, I had to do the
You're having trouble with things when you don't have the software installed? Yeah. So we're just going to go here. Click on this. We're going to download this real quick. And then we're just going to extract it to this folder. It's going to pop over. One's way, you can say, oh, this got the 1, 2, 3, yeah. Because there's another sitting up there too that I don't think I put up there. No. Why does she have better information?
Also,
We need to extract them first. We're just clicking in the zip file there. Make sure you click on the extract first. Everything open for you, Barbara? All right. If you want to install it on your own computer, those of you up here, those of us join us online, we can go to the very bottom. So if I go to Blackboard here, close, go to modules, I go to the very bottom here. That's where I'm going to the bottom. I got a link to the software. I got a link to a bunch of software you're sitting here. But you can click on ArcGIS Pro 3.0. And we're using the latest software called 3.0 because it made me, for some reason or another, I had to do it. I think someone installed 3.0 on here, so I'll blame them. But it's got software. It's got stuff like drone to map because we did some drone stuff, Camtasia, so you can do screen recordings, Pix4D, some other things right here if you really wanted to. WebODM is open data manager. We won't care too much about those. And then in addition here, while we're here, we're going to open up the actual Word document and a couple of these Word documents. And so for all of my homeworks, what you're going to do is you're going to fill out the Word document, answer the Word document, and turn in the Word document for homework. Pretty straightforward, and I'm just going to grade the Word document. In this class, you can work with people on it. That's more than fine because midterm time, come final time, we're going to make sure you have the skill. You're going to make sure you have the skills. So for some of you who haven't taken this since the spring, or some of you who are learning this for the first time, this is going to be pretty neat. You can see for this exercise right here, I've got a video here about geostatistics. So basically, watch the video, answer some questions, and then for the rest of it, we're going to start opening up this software and kind of learning about some things right here. So those of you learning this stuff for the first time, kind of sit back and look at it. But we're going to open it up. And when we open up this software, obviously you see a map floating around here. Those of you, kind of Lauren and Benjamin, who've taken this class and done really well, Mario, who've taken this class and done really well, you kind of know what you're looking at here. But when we open this up, over in the left right here, we got something called the table of contents. These are called layers. And most of you have already seen enough maps in the real world or online maps to know what we're looking at. So you can check things on, check things off. Because what we're looking at here is every person who died of cancer between the years like 2006 and 2010. Because we had a former student who was a leukemia. I don't think it was leukemia. It was Hodgkin's lymphoma. And he wanted to see if there was a relationship between point source pollution and cancer death rates. Pretty neat project. He never did it, not because he's still with us, but he kind of took on another project with the city of Oxford or something like that. But what we're looking at in the left here is cancer deaths, and over in the left, I've got this table of contents here. On the map right here, if I move my mouse around on the map, what do you have going on in the bottom? These things right here, 81.365, little circle sign west, 35.236751, circle sign north. What are those things? What are these here? Here's your latitude and your longitude. In particular, actually, it's longitude and latitude. Why is it reading longitude and latitude? Why does this say, because I say latitude, longitude, you say latitude, longitude, but this thing says longitude, latitude. Why is it saying longitude first? In math class, what's first, the X or the Y? X. Tamar was right, because longitude is your east-west distance, which measures your distance east and west of the prime meridian, where that latitude is your angular distance north and south of the equator. And so in the left right here, I can check and uncheck cancer deaths. Now, under the cancer deaths, all I have is an outline of North Carolina counties, because what we're going to be doing is building upon this map. So next week, we're actually going to look at a map where all these cancer deaths are grouped by county. And so all of this kind of the first 3 or 4 weeks with this data set is going to be cumulative in nature as we learn and acquire or relearn some of the skills that we have. In this particular, what we're going to be doing today is pretty basic, and then we'll kind of hop onto the spatial joins and all that other good stuff. In addition, I've got counties. And if I really wanted to, I could kind of double click and I can change the colors of these things. So I can change these to, red circles or whatever I want, or, black circles, and change the properties and change the colors and change the point setting and, and everything else. So I can make them look a little bit different, because at the end of the day, we're looking at all these points right here, and there's a lot of them. And so I start looking at these. How many of these points do you think are on there? Already? 1, 2, 3? No. We're not going to do that. Okay? Not going to do that. And like I said before, there's a one-to-one relationship with each of these points, which have real-world location and an entry in the database. Are you all set there, Jill? Is it open for you?
Oh, no.
What about?
Oh.
No. It is. Okay. Now, how many of these points are there? This is good. I don't want to say tricky part, but to me, the biggest tool you have out there is the right mouse click. When in doubt, right mouse click, you're going to open up some brand new stuff. And so when I look at cancer deaths, I right mouse click, I got a whole bunch of new options. I can change the properties and the symbology that I just did by double clicking on it. I can look at pop-ups, metadata, properties, but up at the top I can click on Open Attribute Table. So I can click on Attribute Table, and so now I've got a one-to-one relationship with all 102,699 cancer deaths and where they are on a map. So I've got that one-to-one relationship. So if I were to click on this one that happened to be number 6, you can see it's highlighted up there. And you can see it's actually located in Burlington. I probably should have taken the address off of it, but it's neither here nor there. Okay, and I actually got this from the state demographer, who gave me literally like a list of every single person who died by their address. Pretty neat stuff. Now, some of the other stuff that I worked with in the vital statistics database, I've got this thing called like DTHDATE. Death date. I've got attributes to describe these. Sex 1, Sex 2, Sex 2, Race 1, Race 2, Age code, settings, date of birth right here. And so at the time we got the data, these were all of the attributes used to collect these. All the attributes used to collect these. And then you can see right here, like I said before, these are cancer deaths. So the code that they died by starts with the letter C. So I asked them, I put in a data request to get this as part of this project. And so now I can map these however I wanted to. Now what we're going to be doing in this class right here is just kind of a rehash of everything that we've kind of looked at and done or whatever here. I don't think I can click age, sex. It looks like I can calculate the age in years at some level here. But when I start looking at this database here, start looking at the questions here is, what's the geometry type for NC cancer deaths? Now, we start getting into GIS, and those that we take it before, we've got points, lines, and polygons. For the cancer deaths, what do you think those are? Points, lines, or polygons? Points, right? It's points. How do I know it's exactly points? How would you know that it's points? One is they're represented as little circles. What do you think a line is going to be represented by? Well, a line. What kind of features do you think would be represented by lines? Streets, rivers, earthquake faults, hurricane paths. And then we've got polygons. What is something that would be represented by a polygon? Buildings at a high scale. What are you going to say, tomorrow? Counties. Exactly. That's a good one. We got in other counties, states, countries, or whatever. Things that are phenomena that have area and have perimeter. So things that have area and perimeter would be represented by counties here. So how many features are in the NC cancer deaths? Right mouse click on the attribute table and look for 102,699. 102,699. Right here. So this table right here goes down 102,699. You can look at all those. Now, for the NC counties, how many records are going to be in the table for NC counties, you think? How many counties are in North Carolina? 100. So you only have 100 in there. You got 102,000 that represent each of the points right here where someone died. And what we do in our intro to GIS class is we open up these maps, we make pretty maps out of these, and we also can query the data, meaning that I want to find all of the people who were race 1 or sex 1, because that's where we look at disproportionate rates here. If I were to look at the percentage of African American population versus the percentage of African American population that died of cancer and find those to be different, that's the whole kind of underpinning of disproportionate mapping, or Native American, or Hispanic, which is technically like an ethnicity as opposed to a race. And so when we look at disproportionate health outcomes, these are some of the things that we're looking at right here, that we can query out here. Where we look at the percentage of those. And if you look at that paper that Alana did, the one thing that she found was that the average age, because she focused on African American, the average age of African American cancer deaths was a lot less than the other races. Do you think that's coincidence? I don't. Now, the why work with people in public health to do those. But we have very rich databases that look at that. Now, in particular, this was like deaths from 2005 to 2010 or something like that. But these are still important. So that's exercise 1. Question number 3. The attribute race refers to the race of the decedent using the codes in the layout tables document. What percentage of decedents were white? And so a lot of times what you need to do is you got to go, got this layout tables database, and Benjamin already told me I don't have race in here. Is that correct?
It's just references table F, which is in the document.
Oh, references table F, which is another document. But in this case here, since someone didn't put that in there, references another table. Let me find it here for you, because I'm really, because if I think of it tomorrow, I'll post this for everyone. Come on. race equals 1. White is 1. White is, yes. That looks like it's 1 right there. I got to find the other table for that. The one thing that you start to notice is that all of their schema is in different tables, and it gets really, really ugly really quickly, and I can find that. Did anyone see vital statistics database here? Come on. Yeah, getting old. This is where I downloaded it from. So right now you can see the deaths for 2021 just got published up here like 2 months ago. So if we want to look at everyone who died in 2021, 2020, these are the recent things. So Elena and I didn't do these until we didn't include this in our work because these weren't available until last month. But this is where I got these data from, and then I attached it to points, lines, and polygons. But if I were to click on this right here, this would have a description of everything. This is the data set description. And so I can open this thing up. I can open this thing up right here, and this should have this is the F that I think he was talking about, right? So under race of decedent, we can see that white, black, or African American, American Indian or Alaskan Native, or other. And then it has ethnicity, since Hispanic is not necessarily a race according to census, it's a ethnicity. And so we've got Cuban, Mexican, non-Hispanic, Puerto Rican, South Central American, or unknown. And so we can break those down even further. And so this particular question right here, and hopefully we have a little bit of an appreciation of all the pains that go into making data, because you start working for an environmental firm, or you start working for state demographer or the NCDOT, and we had a student named Mike. Do you remember Mike Wallace? He just got a job with the North Carolina Department of Environmental Quality, collecting all their GIS data. Is that these things are going to change, or you're going to be the ones who help dictate the schema and all this other good stuff. And so the question is, how many of these have a race of 1? Now, up at the top right here, we have something called select by attributes and select by location. So what we want to do is select by attributes. So this is pretty straightforward, very straightforward, where that I want to make a new selection where I want to pick the attribute where it says race is equal to 1. So I'm going to generate a query. This is called SQL. Has anyone heard the term SQL before? Structured Query Language. Back in the day, and I think Alvan might remember this, where you had to generate race equals 1. These days with ArcGIS Pro, I can go to these little drop-down things right here, and I can click on the attribute, I can click on the qualifier, and then I can click on the value. You got it here? Oh, because you put the word in, and it's like, hey, I don't know how to make that word in. Okay, it was bad, and because I don't know how to do that. You messed something up. You didn't beta syntax here. How about you, Barbara? You got it. And I'm going to kind of assume you guys are all good. Then I'm going to click apply. And what do I have here? 80,542 out of 102,699. Can you calculate a percentage of those? Yes. How would you do that? 80,582 divided by 102,699, which is about what? 79%, something like that.
Where'd you get the one from? Trying to do the query. What'd you do?
Oh, the one I got from
Sheet
this,
or something?
yeah, the one I got from this document right here that said race, white equals 1, black or African American equals 2. And in this particular question, I just asked for white. Because we can look for black or African American race equals 2 and say, hey, we make up, that group made up, 20% or whatever. And this is just cancer deaths. So this is just cancer deaths. And so we can look up all different types of deaths from that database. It gets really powerful really quickly. And so we would just answer the question right there. Okay, what percentage of decedents? And so I'll just do a little bit of math. So it was like 80,244, whatever, divided by 102,699. So I got about 78%. So about 78% were white. So 78% are white. Next one. The age attribute age units refers to the age of the decedent. What percentage of decedents were 30 or below? So somewhere in here, there is something that says age units, however old the person was. I might have to go all the way to the right. And so now we can see the age of the people who died right here. So this person right here was 59, 51, 58, 77, or whatever here. And so I'm going to create another query right here. I'm going to go all the way to the bottom. Age units. What? Less than or equal to 30. Or I could just say is less than 31, right? Because we kind of rounded these units out. Let me look at the wording. For age 30 or below. Okay. So I can say is less than, or I can say is not more than, however we read those. And we know the difference between less than versus less than or equal to from math class back in the day. So is less than 31 or is less than or equal to 30? Either one's going to be fine. Is less than or equal to 30. I go to age units. Do that. I was just making sure you all. Thank you. Yeah. So now these are all the people who died of cancer under the age of 30 during this particular time period. So 841 divided by 102,699, that'll be about what? 7.5%, 7%, something like that. And we also have a map here of every single person who died of cancer under the age of 30. Are there some things? Now, obviously, there's more dots. What do you think that means? That's where probably more younger people live, higher population. But then we can also start to tease those out in terms of percentage of rates, age grading, all those other things that your biostatisticians are going to do, as well as some of the other things that we talk about. We have some really powerful tools here we can look at. And what we're doing here is just kind of going, we're going to go through the homework here. I want to get most of it done here. Number 5 here. What percentage of decedents were between the ages of 40 and 60? Okay, we're between 40 and 60. All right, so age units, instead of is less than, I'm going to say is, how am I going to do this? Is there anything here that says between? Aha, so we can do a couple of things here. We can do age units is what? Is greater than or equal to 40. What else needs to be true? And age units is less than or equal to 60. Remember that stuff on the number line way back in the day, like 8th grade? We had the little number line right there. It's kind of coming back here. Okay, what's the word and mean? They both need to be true. And so now I can click for everyone between the ages of 40 and 60. I'll click apply. This is everyone between the age of 40 60. Just for the heck of it. Hey, let me make sure everything that's highlighted satisfies that criteria. So I see highlighted here a 59, a 51, a 58, and a 56. Does that satisfy between 40 and 60 inclusive? Yes, it does. Okay. And now the one thing about our software is that it's really powerful and it really vets out what we call syntax error. Syntax error when you type in the wrong stuff. But it doesn't vet out what we call logical errors. You do stuff wrong. Okay? If I were to change this and to an or, what do you think is going to happen? It's going to get everything. Why? Any age is either going to be greater than 40 or less than 60. I can't think of any age of person. So a lot of times people, especially in the intro level classes, are going to say, oh, 102,000, that's the answer. And people go on to the next one. Sometimes we run into that with like homicides. How many homicides occurred in Durham? And they do an incorrect query and they get like 25,000. Does 25,000 make sense? I hope not. Does every single person in the database happen to be between the age of 40 and 60? Probably not. So at the end of the day, who is the final check for QA/QC? It's not this computer. The computer is only doing the stuff that you ask it to do. If you ask it to do the wrong stuff, it's going to give you the wrong answers. So you're always going to be the GIS at the end of the day. I used to say, the GIS is only as good as the person using it. So you just, how many of you are going to notice a little difference between an and an or? I'm not gonna. I'm just kind of going on autopilot, clicking through things. Uh-oh, this number looks a little odd. I better change it. So those are some of the challenges that we've got. And part of the Esri exercise that I've assigned that's going to be due in 2 weeks is just doing an intro to GIS where it covers all this stuff. I've also posted a lot of videos here as well. What percentage of decedents were born outside of North Carolina? And then, yeah, let's try to do these 10 here, and then we'll kind of leave the map for you here. I do want to get out of here at 7. I gotta come into hit on the way home. So the next one says, how many people were born outside of North Carolina? Ugh. So I've got to refer to this database. Okay, let's see what I got here. Okay, I got manual. I've got state they were born in. Because a lot of times, if someone were to get cancer, what causes cancer? Environment, probably health, genetics, smoking, all this other stuff. So if you lived in North Carolina for a year and died of cancer, is it really, quote unquote, North Carolina's fault? Not necessarily. And so we'll see in some studies where they vet or get rid of the people who are actually born outside of the state. And so when I look at this here, I've got death date, age code, year, birth state right here. Okay. All right, so I got BTHSTAT. Okay, so when you die, actually, they keep track of what state you were born in. What state you were born in. And I believe North Carolina is 34. So we're going to go look for everyone who isn't 34. And so we've done greater than, we've done less than, we've done equal to. Now we're going to do something that's not equal to. And so when I go to attributes, I'm going to say, okay, let's see. I'm going to go to birth state is not equal to, and these are all the states where people were born in. I'm going to type in the word 34. And some of the things that you kind of notice that these numbers are left justified, so they're kind of treated as text as opposed to numbers, like greater than, equal to, greater than or less than, even though the GIS is kind of smart enough to say, hey, this is text, but you notice like birth county is 035, so it's treating this as a text because it shouldn't start with a 0. This is, you start with a 0. So I'm going to click apply. So now you can see 36,000 out of the 102,000, they weren't even born. They were not born. I'll make sure this is right. There we go. All right. So now under birth state right here, 33, 11, 41, 35, 49, 41. And we can look up what those codes are. You all sit there, Barbara? You got it? Okay. So you can ask really, really pointed questions here. Really pointed questions here. Now, what we're looking at here are examples of attribute queries, asking questions of the table. But I've got a whole suite of tools and capabilities where I can actually look at the attributes. And the next question says, how many of these people were in Durham County? So the next one says, how many cancer deaths occurred in North Carolina? And so for number 6, all you're going to be looking for are the people who aren't 34. Whatever state 34 is. It kind of aligns with those FIPS codes. Remember, North Carolina's FIPS code is what? 37, but also includes things like Puerto Rico, Virgin Islands, all those other things that kind of tweak that number up a little bit, that bump that number up. Okay, next here. I want to find everyone who died in North Carolina, Durham County. The first thing I got to do is I got to pick Durham County. How do you pick Durham County? How do you make it blue? A couple ways. You could open it up in the attribute table and look for Durham County. I can do a little selection. I can just say, hey, look, there's Durham County. I just picked it out so it's outlined as blue if you know what Durham County looks like. What I did was I unchecked the cancer deaths first so I could actually kind of figure out where it was. And I can go select it. So under select by attribute, select by location, I also have another thing that just says select where I can grab it by a rectangle or do whatever I want. I can go look for it if I want to. Or I can just kind of hunt and peck and say, where's Durham County? Where's Durham County? Go through and look. So once you uncheck the cancer deaths, zoom into it up here. Go over a little bit and put this little select. Just click on Durham County. Just uncheck the county. Check the. All right, you know where Durham County is? There it is. All right. So it's highlighted in blue. And basically, if you highlight it in blue on the map, it's highlighted in blue on the table. Now we would go to this 100 records right here. If we were to go down to Durham County, Guess which record is highlighted in blue? The one for Durham County. So there's a lot of ways you can pick it. Meaning I could just open up the table, go look for Durham County. I could run an attribute, name equals Durham, whatever I wanted to. We're just practicing a little bit of our North Carolina geography, so next time we know where it is. And so what I want to do here is I want to pick all the dots that are in blue, that blue thing here. So now this is going to be a select by location. So I'm going to select by location, and what do I want to pick? I want to pick the input features or counties, so I want to pick cancer deaths that intersect with NC counties. So what I want to do is pick the cancer deaths that intersect with NC counties. I can do lots of things here within a distance of or identical to. Oops, hold on. Hold on, let me. Do this again. Let's do this again. All right, location. Input features.
Person had that and the.
Okay, I'm sorry.
Words on the top.
Yeah, okay. We want cancer deaths intersect with counties. Okay, sorry about that. I was picking multiple things at the same. So we want to find all the cancer deaths that intersect with the North Carolina counties. Why is it just going to pick that one? Because it says records to be processed. I want to find all the intersects that intersect with counties. What are you going to expect? Here it is. What we're looking at now is we've got 2,397 out of 102,000. In addition, we were looking at examples of like disproportionate mapping, meaning what percent minority versus the percent minority deaths. We could also do it geographically, meaning how many people died in Wake County versus the percent of the people who live in Wake County. You know, if 5% of the people in Wake County died over this time period, but only 2% of the people live in Wake County or whatever it is, big difference. Big difference. So now we can see 2,397 of those people live within there. We can do other things like within a distance of, so we can look at things like buffers, like the sex offender website, because what we're going to stick with for the next couple questions are keeping with this data set, because we have 2,397, but how many of these are under the age of 50? So now we've got something called select by attributes, where instead of a new selection, I can just say, hey, pick everything from the blue things that you picked. So in addition to new selection, I've got something called select from current selection or select subset from current collection. You went through the trouble of picking everything spatially. Now I'm going to say, instead of looking for everything in the state, just pick from the blue things, blue points. And so now, what do I want to look at? Age, what? Less than 50. Let me make sure I read it right. Under the age of 50. Okay, so this time we're not going to include 50. And I'm going to click apply over here. Now we've got 209 people who died in Wake County who were under the age of 50. We can see all the age units right here as well. Okay, does this look right? Anything in blue, there's only 209 points out of 102,000. Now we're really specific. Under the age of 50 and in Durham County. Because the next question is going to say, how many of these were born in North Carolina? How many of these were born in the state of North Carolina? And from this, we'll do the same thing again. Select subset of these. I want to say, okay, birth state. Is equal to 4. Now, when I run this, is this number going to be more than 209 or less than 209? Better be less than 209 because we're picking from this subset. Because every once in a while, people will click new selection. You'll get some big nasty number like we had earlier in the exercise and put that answer in there. So we're looking for people under the age of 50 that died of cancer in Durham County. We're looking at a really small number. I'm just going to click apply. Here we got 107. So now, blue dots, the 107 people who were born in the state of North Carolina who died of cancer in Durham County under the age of 50. Wow. Yes. Challenging yourself right there.
Can I ask you while we're here? I like the answers. Do you kind of give us like a plus or minus? Just because I was looking at depending on the way that you did the query, if you actually queried the data, the number would be a little bit less for both of those versus like the selection that you did.
Yes.
And then also you did intersect and not within, so
yes.
that can kind of skew it.
Yeah, that's a great question, Alvon, meaning that I did intersect versus not within. So if someone happened to live right on the county border, they wouldn't be in a county. So I said intersect, but he did it within. So instead of 209 or 2032, it might be 2029 if someone's address was right on the border. Or if it had county, if you picked the county, well, I know Durham is county number 23, pick county 23, but I just picked the outline of county 23 where it moved you 5 feet on the other side. That I'm not going to notice 5 feet on this map. So yeah, Alron's, that's a great question. Yeah, there's some flexibility with this. So is everyone feeling good about these here? Kind of working your way through a little bit. Now for next week, we're just going to finish the rest of this up. Tomorrow, what I'm going to do, because I got to get out of here, I got to meet my parents over in Burlington. What I'm going to do is I'm going to post a tutorial on how to do the last one. It's using something called a spatial join. And then I'll also post what we need to do. You're kind of, we got to revisit those. And then in addition, exercise that we'll post next week is that in 2 weeks from now, if we go to training.esri.com, anyone who hasn't done it before, you do the intro to GIS tutorial. And so if we go to right here, if we go to modules, I've got an Esri training, Esri assignment. And what you're going to do, you're going to go to training and you're going to take the Getting Started with ArcGIS Pro. So I'm just going to go to the Esri training. My little course catalog. Type this in. I'm going to take. Is it on here? Or did they just get rid of that class?
The last time it was hard. I did.
It's under that first the left, that learning plan, you have both fundamentals. It's probably like first school.
Yeah. I have to give a different class. It might be ArcGIS Pro Basics. This is just a little web course. It's usually I have to give a different class here, but you can see some really neat ones here. Mapping disparities in breast cancer mortality using ArcGIS Pro. Like, this is the stuff people want to look, you're a PhD student. This is what we did here. Let me send an announcement here. If there's another intro level GIS, they must have traded out that class. But you're going to go to here and take the class, go through, take the class, do the video. It gives you a little certificate that says congratulations. Those of you who've taken my classes before, I give 3, 4, 5 of these each semester. Some of these I have you pick out. Some of these, there's some neat ones here. Maybe I'll give you that short one up top, which is the ArcGIS Pro Basics. It's 50 minutes. You kind of just go through, do it. But I'll send something definitive tomorrow because maybe it's sitting somewhere behind, like Alvon mentioned or whatever. So I'm on the lookout for an announcement for me tomorrow. But at this juncture, we know how to install stuff. We're going to open up this GIS software and we can open up our projects. And so those of us will kind of shorten the learning curve with those of us new to GIS. Those of us who are really good pointers and clickers will kind of get a lot more data literate about how to create graphs and charts and everything else. So without any further ado, we'll bid everyone good night and see you next week. Be on the lookout for some things from me and kind of finish these up as we finish everything up. All right, see you later. All right, all set? Everyone get everything here?